For our lesson today, we're going to be solving inequalities using addition or subtraction. An inequality is a statement formed by placing an inequality symbol between two expressions. Note, inequality signs look like as follows: less than, greater than, less than or equal to, greater than or equal to, or not equal to. Those are all called inequality signs. Now, in order to solve an inequality, the solution of an inequality with a variable is the set of all numbers that produce true statements when substituted for the variable. So, for example, I have y plus 5 is less than or equal to negative 6. You have been accustomed to solving equations. Now we're going to solve inequalities, and we'll use the same rules in addition and subtraction of equality. So in order to solve for y in this inequality, we're going to again isolate the y. So we're going to subtract 5 from each side. Y is less than or equal to negative 11. Now, as we continue this lesson, I'm going to teach you how to solve an inequality and how to graph it, and what actually an inequality means. You can show the solution of an inequality by graphing the inequality on a number line. When you graph an inequality of the form x is greater than a, or x is less than a, use an open circle at a. When you graph an inequality in the form of x is greater than a, greater than or equal to a, or x is less than or equal to a, use a closed circle at a. Now, I'm going to demonstrate these examples in the next few slides. But again, in an inequality, when you're solving it, your goal is to isolate the variable, and you will use, in this lesson, you will use your addition and subtraction rules that you have been using in solving equations. And in reading an inequality, we have x is less than 3. In words, that means all numbers that are less than 3. In the next inequality, y is greater than 2, that are all the numbers that are greater than 2 will make the inequality true. The third example is z is less than or equal to 4. All numbers less than or equal to 4 will be the solution for the inequality. And the last one is n is greater than or equal to 2. All numbers greater than or equal to 2 will make the inequality true. So let's move to the next screen and talk about how we are to graph an inequality. In our first example, we have x is less than 3. When you're asked to graph this, you will graph it on a number line. So you have a number line here. Just plot a 3, and then fill in the numbers. Now, our inequality states that x is less than 3. So I'm going to go to 3, and I'm not going to close in the circle. I'm going to have an open circle, and inequality is representing all the numbers less than 3. So I will show this example as open circle because it does not include the 3, but all numbers less than 3. In our next example, y is greater than 2. We're asked to graph this inequality. So you draw a number line, plot the 2, and for this inequality, y is going to be greater than 2, so it includes all the numbers greater than 2, but not actually 2 itself. In our third example, we have z is less than or equal to 4. So I'm going to plot 4 here. Now, in this equation, it says z, all numbers that will be less than or equal to 4. Now I'm going to close circle the 4 because it includes the number 4, and it is all numbers that are less than or equal to 4. In our last example, we have n is greater than or equal to 2. I'm going to plot the 2. And since it is greater than or equal to, I'm going to close circle it because it is including the 2. And the solution for that inequality is all numbers that are greater than or equal to 2. One thing I want to note when you're graphing an inequality is, notice in each of these examples, the variable is on the left. And then the inequality sign is showing which direction your arrow goes. So for example, if your variable is on the left, note that the inequality is pointing to the left. That is the direction that your graph will be pointing to. In the second one, y is greater than 2. The variable is on the left, and this indicates which direction that the graph will be pointing is to the right. So in each of these examples, if your variable is on the left, it indicates which direction that you will be graphing on the number line. So now in our next example 1, writing and graphing an inequality. Science. The freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is solid, or ice. Write an inequality that gives the temperatures at which water is solid. Now in our solution, they're prompting us to let T represent the temperature of the water. Water is a solid at temperatures less than or equal to 0 degrees Celsius. So since they have asked us to use a T for our variable, we're going to use the T. And we need to note temperatures that are going to be less than or equal to 0 degrees Celsius in order for the water to form a solid ice. So all temperatures that are less than or equal to 0 in water form ice. So now we're going to graph this inequality. I'm going to place a 0 here. Now you don't always have to graph in single digits. You can go in tens, 20s, you can go in 2s. But for the sake of showing an example of temperatures where water can freeze to ice, I have chosen to use them by 10. So I am including the 0 degrees because if it is at 0, then it will freeze. And then notice the variable is on the left. The direction of the arrow inequality is going to the left. So here is how you would graph T is less than or equal to 0 degrees Celsius. Now when you're solving inequalities, you can use the following properties to find solution of inequalities involving addition and subtraction. Using these properties, you can write equivalent inequalities. Equivalent inequalities are inequalities that have the same solution. So we're going to use these properties. We're going to use addition and subtraction properties of inequality. In words, adding or subtracting the same number on each side of the inequality produces an equivalent inequality. Now, as we go to this next screen, you will be able to understand the previous screens a little bit better. In this example 2, it's asking you to solve the inequality using subtraction. And then we're going to graph and check your solution. So as we're using the properties of addition and subtraction property of inequality, what we do to one side of the inequality sign, we have to do to the other. So if I subtract 5 from this side of the inequality sign, I'm going to subtract 5 from this side. So now I have m is greater than or equal to 5. Now I'm going to plot this. If I could have started with 5. So I'm also, it is n is greater than or equal to 5. I'm going to include the 5 and denote that. Now let's pick a number, any number that's greater than 5. Tell me a number, Charlie.
39.
39. Let's just do 39 for something easy. So I'm going to plot 39 in here in this equation. 39 plus 5 is greater than or equal to 10. Charlie, what is 39 plus 5? 44. Is 44 greater than or equal to 10? So it is true. So that inequality is correct. And we can check that because any number on our graph that's going to be greater than or equal to 5 will make this inequality true. Now let's see if we put 5 in there, because we've got a closed circle here, which includes 5. So let's put in 5 for m. 5 plus 5 is greater than or equal to 10. 5 plus 5 is 10. So 10 is greater than or equal to 10 makes this inequality a true statement. Okay, let's solve this inequality using addition. Again, we're going to use the property of addition and or subtraction of inequality. So in this example, I'm going to add 12 to each side. Negative 10 plus 12 is going to be 2 is greater than 12. Excuse me, greater than x. Now, this is the same as x is less than 2. Both of these are true statements. If you have 2 is greater than x, or x is less than 2. Now, as I'm going to graph this, I'm going to graph, put 2 here. It does not include the 2. So now I'm going to look at my inequality and know that x is going to be less than 2. Any number that is less than 2, I can plug in for the inequality to be true. Did I hear 1? Okay. So now negative 10. What is 1 minus 12?
Negative 11.
Negative 11. Negative 10 is greater than negative 11. So you'll notice that any number that you put in that is going to be less than 2 will make the inequality true. All right, let's solve the inequality. We're going to have some practice problems now. Let's solve the next 4 inequalities and graph them. So now we have in this inequality, n is greater than negative 4. Open circle because negative 4 is not included. Any number that we put in for the variable n that is greater than negative 4 will make the inequality true. Let's move to the next example. 10 is greater than or equal to y plus 4. Need to isolate the variable. So I'm going to subtract 4 from each side. 6 is greater than or equal to y. Or you can have y is less than or equal to 6. I'm including the 6 because that under y is less than or equal to 6 includes the 6 in this inequality. Example 3, negative 6 is less than or equal to x minus 9. Negative 6 plus 9 will be 3. Ooh, excuse me. Close circle because x is greater than or equal to 3. Last example of this type. Open circle, z is less than 6. Any number that you put in that is less than 6 will make this inequality true. Now, in example 4, writing and solving an inequality. A triathlon. You're competing in a triathlon, which is a sports competition with 3 events. Last year, when you finished the triathlon in 85 minutes, the table shows your times for this year's first 2 events. What possible times can you post in the running event and still beat last year's finishing time? I'm going to pause the video, see if you can set up an inequality to determine what your running time needs to be in order to beat the 85 minutes. So it has to be less than 85 minutes. So you'll notice in our equality that we've chosen C for the variable for running. So C plus 17 minutes, which is our swimming time, plus 45 minutes biking time, all that needs to be less than 85 minutes. So we combined our like terms, which is C plus 65 needs to be less than 85. We subtracted 62 from each side, and our time needs to be less than 23 minutes. So in order for you to beat last year's 85 minutes in your triathlon, your running time needs to be less than 23 minutes. All right, now I would ask you to read example 5, set up an inequality, and I'll come back and we'll check the answer. Okay, in this word problem, on the first 2 math tests in math class, Colin had scores of 89 and 95 points. The third math test is tomorrow, and Colin's goal is to have a total score of 279 points or higher on the 3 math tests in order to have an A average for this quarter. What possible scores, S, can he have on the test tomorrow to attain his goal? Now you'll notice we set up the inequality of 89 plus 95 plus S. Those total math scores need to be greater than or equal to 279. All right, so we now have combined the 2 math tests. 184 plus S needs to be greater than or equal to 279. We subtracted 184, so the score on Colin's last test needs to be greater than or equal to 95. Now tomorrow we are going to solve inequalities using multiplication or division. They have almost the same exact steps except for one difference, and we'll talk about that tomorrow.